In this video, we're going to do an example that has the chain rule and a product rule. Just because we're using one of our rules doesn't mean our other rules go away. We might have to use more than one of these on any given problem. First, let's refresh our chain rule. All right, we have an outside function and inside function. It's the derivative of the outside with the inside intact times the derivative of the inside function. In this example, however, we have two functions that are multiplied together, and each of them has an outside and an inside, right? So there's going to have to be a product rule here. We're going to have two things multiplied together. And for each one, we're going to have an outside bit and an inside bit. An outside bit and an inside bit. So first, let's remember that in a product rule, given some f of x and a g of x, it's going to be the derivative of the first times the second plus the first times the derivative of the second. Okay, so let's let 6 minus 2 to the 12th be f, and let the cubed root of 7x plus 5 be g. All right, so first, let's talk about f, okay? We have an outside function of blah to the 12th. The derivative of that is simply our power rule. So O prime for f is going to be 12 times blah to the 11th, right? We bring down the 12, we subtract 1 from the power to do our power rule. The inside for f is just this really simple linear bit, right? It's polynomial. 6x minus 2. So the derivative of the inside is also going to be nice and straightforward. It's just going to be 6. So I prime of f is 6. So putting these pieces together gives me f prime. So f prime is going to be our 12 times our inside bit to the 11th. Our inside bit stays together, 6x minus 2, times our outside function, a derivative of the inside function of 6. Okay, well, 6 times 12 is 72, so I could write f prime is 72, 6x minus 2 to the 11th. And that's how I have it written here, right? The f prime is 72 times 6x minus 2 to the 11th. All right, now let's look at g. Well, g is the cubed root of 7x plus 5, right? Our outside function is this cubed root. It's the piece on the outside. So our outside function is the cubed root. Now, if you remember back to power rules, the cubed root has a power of 1/3. And we know that the derivative power rule works on these fractional exponents as well. So we'll bring down the 1/3 and subtract 1 to get O prime. So O prime of g is going to be 1/3 times the inside bit. 1/3 minus 1 is going to be negative 2/3. All right, so written a little more nicely, O prime is 1/3 blah to the negative 2/3. Now, we can simplify this a little bit. This negative means I can write that at the bottom of the fraction. This 2 up top is a square, and this 3 on the bottom is a cubed root. So this is going to be 1 over 3 times the cubed root of the inside of g squared. Fortunately for us, the inside of g is a little more straightforward, right? Our inside was 7x plus 5. That's polynomial. It's nice and boring. The derivative of the inside of g is simply 7. Okay, so putting all these pieces together to get g prime, we get g prime is the outside of g, 1 over 3 times a cubed root of the inside, 7x plus 5, quantity squared, times the derivative of the inside, which is 7. And if I wanted to, I could write this as 7 over 3 times the cubed root of 7x plus 5 quantity squared. Or, written more nicely, g prime is 7 over 3 times the cubed root of 7x plus 5 quantity squared. Now, to put the original derivative back together, it's going to be f prime times g plus f times g prime. Give that a try, put them together. I will show you what I got here in a second. So I got at last that the derivative of 6x minus 2 to the 12th times the cubed root of 7x plus 5 is 72 times 6x minus 2 to the 11th times the cubed root of 7x plus 5, f prime times g, plus 6x minus 2 to the 12th times 7 over 3 times the cubed root of 7x plus 5 squared, f times g prime. And that is our result.